and know what you're doing.
Did the wrong way around.
This is just keep copying it over.
Please,
Okay, so it's synthesized for me.
Wait for it. For it.
Oh,
Yep.
Okay.
There you go.
God, it's so satisfying.
I know, right? And on the first try.
I mean, that, yeah.
Where, how do you synthesize?
go to implementation, go down to the bottom.
There we go. You're looking the right way.
I want this video. This video must be pretty hilarious to just play while you're doing nothing.
Are you guys doing all right over there?
Invalid use of input signal CI is
Target
target.
out I do. Okay. Uh-oh. CSSE.
Did you do carry in for all of the?
That's
This is a snazzy little phone charger system over here.
The order.
Yeah, I got that this summer for all my prototypes I had to deal with. I kid you not, I had 5 prototypes at one point.
How do you speak?
Yeah. It was cool, but it was insane because every outlet in my apartment was taken up.
Yeah. More power strips.
Oh.
Oh. Yeah, there you go.
Let's see, let's go ahead and bring up the ALU here.
Oh. No, isn't that supposed to be add one? Okay.
Yep.
You check this out right here. Oh yeah, it's add or one. But I named my thing lowercase a.
This guy right here needs to be the module that you're using.
Oh, okay.
So it needs to be adder 1b.
I use lowercase a, I think.
Yep. For lowercase a as well. Yep. Think of it just like you're making an object, except the object just happens to also do everything. Yeah. Once you get the rhythm down, it actually goes pretty fast.
What? There's a rhythm to it now.
So close.
There is.
Library.
What if you can't open a library file?
What?
Can't open a library file.
Because I think what the problem was when we were initializing this, because how I had defined the adder 1b was different than you, because I had the input CI at the end for whatever reason, so I just moved it and changed it around. Now I just tried to
Oh, wait,
synthesize
your
and
adder's
it's
screwed up.
still instead.
No, my adder should be fine. It's the test bench for adder. That's messed
Right
up.
click on
16b. What's it says?
Expecting end of
Right
file.
click on synthesize remodel.
It's green.
Yay!
Rerun solves a lot of stuff.
Okay.
Dave,
Dave, do you also know why
why is it
when we add, like for me, whenever we add a source and we add a new source, that original source kind of goes off in the thin air? It's still kind of around, but it's...
Oh, it goes inside of the one. Like if you look up here.
Okay, I got it. Good.
Yep.
Okay.
I have warnings here.
Warnings are okay.
Alright.
Expecting
But
end of file. Found the head.
Yeah.
warnings are warnings.
Oh, that's
not a
useful.
Java doc.
Definitely
Oh.
should be at the end of file.
Oh.
Found A. Oh.
It did find a name.
Mainly because I never commented my code.
That's kind of random. I don't know how an A got up there, but sure.
Sounds funny. This semester.
That should work.
See you guys. Okay, I'm gonna move on. 'Cause it seems like everyone's gotten it now.
Cool.
What does this mean? It's never used.
Yeah. So one thing that you'll one thing you'll notice is that in warnings, at least for some of you guys, you'll be told that temp is not used.
But yeah,
Or
that's what it says.
yeah, because you put in carry in for all these guys.
Uh-huh.
There's need to be the temps going into those. Because the carry out from
Oh yeah.
one bit needs to go to the more significant bit. Carry in.
That's true. Oh my gosh.
Yep.
There we go.
I'm gonna move on.
Sounds good.
That way this video isn't entirely debugging. So you make a new Verilog module, and I'm going to call it ALU16B. Now for inputs, we're going to have A, B, we're going to have an opcode, and we won't have a carry in, but we will have a results and carry out. At this point, it's just kind of whatever you overflow. We'll do overflow. What the heck? And 0. Okay. So obviously these guys are outputs. This guy is a 16-bit bus. These guys are also 16-bit buses. And then this guy, I'm just going to have it be a let's see what's this. It's just gonna be a 3-bit. Again, this is where you guys would change stuff.
Right.
Yeah.
So we come up with this guy. Now, actually the way I implemented it here is not the way you should implement it. Oh, but this is a good time to bring up something. So, one really nice thing that would be useful here is what they call parameter. It's a data type, and it has nothing to do with the circuit whatsoever. It's almost like a constant that you define in C. You know how you do a pound define constant in C? It's the same type of thing. It has nothing to do with the circuit at all, but it's there to make things easier to read. So what I'm going to do here is with the parameter, I'm going to define the different operations and what the opcodes are for those operations. So for example, we'll say add op is going to be 0, 0, 0. Let me make sure. Yep. And then we'll say and op is 0, 0, 1 or op. And then we'll say anything else here that's worthwhile. Shift. I won't do shift. But we'll do neg and not.
What were those last two?
Neg and not.
Negative.
What?
I was
Okay.
like saying like negative. What would negative do? It's
It would just negate it.
like just put the most significant bit to 1, or like actually like just have the same value as negative.
It would be the same value, just negative.
Okay.
And this is something that you would mess with yourself. I mean, at the ALU level, you can customize it however you want. This just happens to be how I did it. Now, at the top, what we need to do is, even though we may not use the result from everything, we still need to actually have all of our modules that we're calling into. So, for example, up here, we need the adder 16B to be put in here, and that's going to have A, B, 0 for the carry in, and then R, and we'll make a wire here. I'm going to make a wire that is add CO, and that's what's going to hold this guy. Actually, what I did here was just adder, which is going to be this guy will be a 16-bit, and then wire adder O. And the reason I did that was because you're going to have if you use any other modules for something like shifting, you're going to want to have different results, and then pick the one that you need to be the actual result. The result isn't necessarily going to be the adder result. So you need to have separate wires and then later on choose. Think of it just like if you were building the circuit, you'd have on the left hand side you have all the inputs, middle you'd have all the modules with the inputs and outputs, and then you'd have the mux. Right now we're putting those modules in the middle.
You want to get every output that you string out?
What?
You're saying we ought to make sure we can access every output? that
Yeah.
can be output?
Well, every result that could be output, yeah. If you could,
The bus definition for the wire should be on the right side of it.
bus definition for the wire here.
Yeah, is that true? The 15 to 0 be
Yep.
after adder.
I'm not sure what you mean.
Should the 15:0 go before or after adder?
It should go before.
Really?
Yep.
Okay. All right. Okay, the last one we had on the other spot.
Really?
Mhm.
I guess it doesn't matter maybe then.
Oh, cool. Whoa.
I'm
something not
amazed.
mattering.
I know, right?